So, you decided to do a physics degree because at A level it seemed pretty cool to learn about how guitars make sound or how planets move. But now you've started your first year, you've met your classical mechanics lecturer, and all of a sudden you're asking yourself if you would have been better off working as a cashier at McDonald's. At least that would get you free fries, and all uni gives you is depression. No worries, we're here to help. So, you probably already remember what angular velocity is and how it works, but here's a quick reminder. So, angular velocity, represented by omega, is equal to v over r, velocity over radius. Acceleration is v squared over r, or omega squared over r. And finally, centripetal force is mv squared over r, because F equals ma, or m omega squared r. So this image may already look familiar. You should know by now that when a planet is orbiting a star, therefore executing circular motion, the centripetal force will act towards the center of the orbit, so along the radius of the orbit, and the velocity will be perpendicular to the radius. Now, let's try to introduce a new quantity, angular momentum, represented by the letter L. You already know of linear momentum, which is mass times velocity, and you know that it must always be conserved in a physical system. Well, angular momentum is the equivalent of linear momentum except for rotational motion, and it must be conserved as well. Mathematically, angular momentum is equal to the cross product of the position vector and the momentum of the orbiting object, and we can rewrite the momentum as mass times velocity. Now you have probably already learned how to write v in terms of polar coordinates, like this, which means we can substitute this formula into the formula for angular momentum to obtain a new expression. Now we can expand the bracket here, and we will notice that our first term will cancel because we will have r hat cross r hat, and the cross product of any vector with itself will be 0. So we will be left with the second term. Now we know the cross product of any two vectors will be another vector that is perpendicular to both of them. Therefore, if we consider an object executing circular motion in the x and y plane, both r hat and theta hat will be along the xy plane, so their cross product will be a vector in the z direction, k. So now we can have a look at the circular motion we have already shown you. We can see in which direction r hat will be pointing, which is the direction of the force, and we can see in which direction theta hat will be pointing, the direction of the velocity. Now we can deduce that the cross product between them will be acting upwards, so this is what the angular velocity vector will look like. Okay, so you probably already know how to represent acceleration in polar coordinates like this. And we will try and use this formula to explain why in circular motion the angular momentum must be constant. Now we know that force equals mass times acceleration, so we can just plug this formula in to get the following expression. Now, we also know that in circular motion, the only force acting is a central one, so we know that the centripetal force will act along r. And this means that force will equal to the first term in our expression, and the second term, which is the term along theta hat, will go to 0. With that in mind, we can return to our definition of angular momentum that we already know. And if we want to find the rate of change of angular momentum in circular motion, we have to differentiate L with respect to time. For this, we will just use the product rule to prove the following expression. Now, we have already proved that this term equals to 0, and we could see it again in the formula for differentiated angular momentum, so we can easily deduce that dl by dt is equal to 0. Therefore, we have proven that angular momentum must stay constant during circular motion. Now, hopefully we have managed to explain the notion of angular momentum a little bit better than the notes you were given, and hopefully now you're less likely to drop out and leech off of your parents until you marry rich.